Giant Leap with Taylor Wilson.
Welcome to Giant Leap. I'm your host, Taylor Wilson. We're here with my producer, Joey Lovato. Joey, I hear you have a question for me today.
I do. Phil Corbett, our producer, and I were talking off camera here about hydrogen cars, something that we'd heard about in the past. Not hearing about it too much in the news now. Electric vehicles are in the news a lot. You have an electric vehicle. Not hearing about hydrogen fueling stations or anything.
Yeah.
What happened there? What's going on? Is that the future?
No, it's an interesting question. And I don't speak to be some kind of oracle, and I might be wrong, but I have some instincts on what's happening with hydrogen. And I think the biggest thing is how I view hydrogen, which is not really as a fuel source. It's really an energy transfer mechanism. I think
kind of like a battery.
Kind of like a battery. I think
Okay.
so many people think of hydrogen as like gasoline. It's like a 1-to-1 substitute. You maybe mine it or suck it out of the ground, and you put it in your fuel tank, and you're off to the races. And because hydrogen doesn't have any carbon in it, it's carbon neutral and all of that. And
Yeah, hydrogen cars put out water vapor, right?
yeah, yep. The product
cool.
of hydrogen combustion or the oxidation of hydrogen is water, and that's great because that's something everyone wants to breathe in, at least in small amounts.
I prefer air, but
Yeah, fair enough. But yeah, so let's kind of like reset the conversation. Like think less of hydrogen as a fuel and more as a way to move energy around. The biggest question really becomes where you get the hydrogen from, because hydrogen is the most abundant element in the universe.
It's the first element on the periodic table.
First element on the periodic table.
I paid attention during chemistry class.
I know you did, Joey. It's a single proton with an electron orbiting around it. It's the most abundant element in the universe. It's like maybe 75% of the matter in the universe is hydrogen. It's super abundant, but because it's reactive, you usually don't find elemental hydrogen or molecular hydrogen. If you go looking for hydrogen, normally you'll find water. Certainly on Earth, that's the most common source of hydrogen. There are a few examples of so-called white hydrogen or hydrogen that forms from geological processes. These are pretty rare. Usually it's either a process we call radiolysis, where naturally occurring radiation breaks down water into hydrogen deep within the earth, or sometimes this process called serpentinization,
Okay, sure.
which is just a chemical reaction with mantle rock that is pretty close to the surface.
Okay.
So if you look around, Morocco has some deposits like this. If you look around, you can find some deposits of natural hydrogen, but probably not on the scale that would make a huge impact on the world's energy supplies.
Sure, we're not like pulling it out like we are gasoline.
No, not like
Okay.
natural gas or oil.
So, okay, can you take hydrogen out of water? Is that like where we're getting it from, or are we pulling it out of gas vents in the ground?
Yeah. So again, not very many sources of molecular hydrogen on Earth, but there are other ways to get it. And unfortunately, the technology community, in my opinion, has come up with this really silly way of talking about hydrogen. They have gray hydrogen, they have blue hydrogen, they have green hydrogen, they have pink hydrogen. It's all the same hydrogen.
Just how you get
That's what they talk about when they talk about where it comes from. I think it's silly. Needless to say, there are different ways of getting hydrogen. So typically it's either, majority today comes from natural gas. Natural gas is primarily methane, CH4, a carbon atom with 4 hydrogens around it. You can take that hydrogen away. The byproduct of that is typically CO2. And so you can get gray or blue hydrogen, where you either just let that CO2 go up in the atmosphere, or you try to sequester it in some way. But most all the studies I've seen have said that when you do that, there are still massive carbon emissions associated.
Sure, you're using machines that use a ton of energy that are from coal burning power plants.
You're still drilling wells and you're doing all this stuff. And so personally, I'm not a big fan of hydrogen that's derived from natural gas.
Okay.
Which is the majority of the hydrogen today. In fact, there is a hydrogen filling station I visited recently. I think the closest one to us is probably the one down in Truckee, and people fill up their cars. That stuff is coming from natural gas. Probably on a pound for pound basis, not kilogram for kilogram basis, not great for the environment. But that is, today pretty much where hydrogen comes from. This is called steam reforming of methane, natural gas, and it is hydrogen that's derived from a fossil fuel. But there
Is the reason that we're using that hydrogen it just isn't it's just not common because we have the infrastructure for fuel, for gasoline, and we have now a budding infrastructure for electricity, but we just don't have this established industry or is of hydrogen, or is it more complicated than just that? It's also not very good.
It's more complicated.
Okay.
I mean, that is part of it, right? It is an infrastructure problem. The reason we see lots of electric vehicles on the road, battery electric vehicles on the road, and not very many hydrogen fuel cell vehicles is the fact that, I can plug in my garage and charge overnight my, pickup truck and I'm off to the races. Most people can't do that with hydrogen. There are very few hydrogen fueling stations.
You don't just have hydrogen coming up out of the ground here?
No, unfortunately not. So that goes back to the first question, which is where you get the hydrogen from.
Sure.
And if we say we want to decarbonize and get away from these fossil-derived sources of carbon, there are actually ways to get it. And I think the most important way is splitting water. If you think of the most abundant source of hydrogen on Earth being water, as far as that molecule, what does it take to separate?
Yeah, is that a difficult process?
It's not difficult. All it takes is energy. So you can use electricity to split or electrolyze water into hydrogen and oxygen. And that goes back to my original statement, which is think less of hydrogen as a fuel and more like an energy transport medium.
Okay. It's just a thing that has energy in it, and then when you put it into, say, a hydrogen-powered car, it's then actualizing that energy.
It's transforming it into a usable form. Exactly.
Got it.
So in the same way that you can take electricity from a power plant, you can send it down a transmission line to your house, plug in your electric vehicle, charge up the battery, then pull that electricity out of the battery and, drive to the grocery store.
I like the way you drive to the grocery store with your feet.
Yep. You can also do that with hydrogen. You can take electricity from the power plant. You can put that electricity into an electrolyzer, split the water into hydrogen, put the hydrogen in the car, then take, in the case of a fuel cell, electricity from that reaction of oxidizing hydrogen and drive your car around.
So is the reason then, okay, again, I'm kind of stuck on this, it doesn't seem like a very good fuel because we're not using it. And so I kind of just assume it's not a good fuel. Is that because it's just we're using energy to make the fuel? And so why would we use energy to make the fuel when we just have that energy and we already have fuel?
Yeah, I mean, I guess the big questions or the big complications with hydrogen relative to other ways of transporting energy around is things like efficiency and materials and technology. Batteries have come such a long way in the past 5-10 years. Batteries have become so good that you can now have a pickup truck like mine that'll go 350 miles on a charge, and it's relatively easy to charge up, and it's very efficient. The electrons that go in and the electrons come out, there's very little loss in that. So it's altogether a pretty good system. The challenges with hydrogen are challenges of efficiency. Also, it's the smallest molecule that there is, and that means that it's very hard to control. It's kind of like a toddler, it's just kind of running around. It's very hard to keep.
I've always said that about hydrogen. I paid attention in chemistry class, and that's how they
as you've told me. It's really hard to keep the hydrogen contained. So you put it in a tube or a pipe or a cylinder. The hydrogen tends to embrittle materials. It tends to escape.
Because it's the first element on the periodic table, it's so small. Is it seeping into things? Is that what's happening?
Exactly. Yep.
I don't like that. Am I getting hydrogen seeped into me?
Probably. There's cylinders of hydrogen.
Okay. Should I be worried?
No, it's okay.
Hydrogen's fine.
I think you're okay.
Okay.
Yeah. But anyway, so that's the problem with hydrogen is it's a challenge to make it. It obviously is just a way to take electricity and, in the case of a fuel cell, end up with electricity on the back end, and in the intermediate, as opposed to in a battery, intercalating lithium ions into an anode.
Oh, sure. I don't know what any of those mean.
Charging up a battery.
Okay.
You have to go through all these complicated steps of making the hydrogen, compressing the hydrogen, storing the hydrogen, moving the hydrogen around. There are problems with fuel cells.
It doesn't operate well in cold temperatures, right? I think I read something about that.
Yeah, I mean,
Is that just more of the engineering of the motor and less about the hydrogen itself?
yeah, and there's some problems with your products of the reaction, water freezing up and things like that.
Yeah,
But
that makes sense.
you have similar problems with batteries and things like
Okay.
that. So at the end of the day, big problems with scaling up hydrogen. Not to say it can't be done, but I think the reason we haven't seen it like we've seen electric vehicles is just it seems like battery electric vehicles just seem to be a simpler technology.
Okay.
Easier to make, easier to manufacture.
It's more abundant. I mean, like, it's just more like readily used. Like, we're not putting hydrogen batteries on our TV remotes the way we're using AA batteries on our TV remotes.
Exactly. And we have all this infrastructure for getting electricity around that we don't have for getting hydrogen around. I've talked to people about proposals to make green hydrogen, electrolyze hydrogen, or get hydrogen from nuclear sources and mix it with natural gas so that you could use the existing kind of natural gas infrastructure that exists to get hydrogen to people's homes. And that kind of is an accelerant or a way to decarbonize faster by mixing hydrogen and natural gas. But at the end of the day, for a true hydrogen economy where like passenger electric vehicles are being powered by hydrogen fuel cells, you're going to need massive infrastructure. And as we talked about, hydrogen's hard to contain, it's hard to seal, it's hard to store, all these things. So I'm a little bit more bearish on that hydrogen economy.
Okay. Well, I was about to add, and it looks like you're going to preempt me. Are there economical futures where hydrogen is used, like in like trains or something?
It's a good question, right? So you're right. I was going to preempt you and say, like, I still think there is a future for hydrogen.
Okay. But it's not going away.
It's not. Well,
we're not going to lose hydrogen.
We're not gonna float it all out into space.
That's good. I like water.
I think hydrogen is still a useful source or transfer mechanism for energy. It has some things going for it. It's actually very dense. Maybe not on a volumetric basis as like atmospheric pressure hydrogen, but compressed hydrogen stored in a metallic hydride lattice, actually has a pretty high specific energy. It has a pretty high energy density. And that can be useful for things. One thing is, a society, we're undergoing this massive transition to electrification.
Yes.
Both in passenger vehicles and buses and industrial processes. Everything is going electric. Just in the same way that early in the last century, we transitioned from gas lamps to electric lamps.
From coal-powered trains to I don't actually know what trains run on.
Electricity. Most of them are hybrid electric. They've got a big diesel generator, they generate electricity, and that runs an electric motor. So yeah, the most common hybrid in the world, by, percentage of the fleet is probably, trains.
Oh, the more you know.
But anyway, long story short, we're undergoing this massive transition to electricity. There are some processes, there are some applications that are really hard to decarbonize, that are really hard to electrify. Some examples of that might be long-haul aviation, transatlantic flights. Steel production is another good example of that. Steel production is really hard to decarbonize because typically we're using a carbon as a reducing source to get the oxygen out of the ore that you're making into steel.
We're going into a different element here. Let's save that for another episode.
So iron steel production is another thing that it's really hard to electrify or decarbonize. Hydrogen has applications in these areas. And if you can get the hydrogen cheaply from an abundant energy source like stranded wind generation or nuclear generation, if you can make it effectively, or even from natural gas in a way that very carefully sequesters the carbon, that may be the kind of hydrogen economy that we see in the next 10 years.
Okay.
Is it going to have the impact that batteries have? My gut tells me, my intuition tells me probably not, but I'm willing to be proven wrong about that. It's certainly
my favorite thing to do is prove you wrong.
Yes, I know it is, Joey. But it's certainly worth exploring. It's certainly worth investing in the technology.
Yeah.
Are we all going to be driving hydrogen cars in 10 years? Probably not. But you might be sitting in a chair that was made with steel that was produced with hydrogen. Who knows?
That's one small step for man, one I am pleased to be